Okay, welcome to part two of these video lecture series on chapter 9. I started off talking by various OSPF areas, the terminology, that kind of thing. Now we need to start talking about these LSAs. We've dealt more or less, pardon that, we've dealt under the hood with type 1 LSAs. Now that we did, once you do the area range or network summary configuration, the router will start sending type 4s. A type 5, if you have um, a route that comes from outside the AS, the autonomous system, that's a type 5 SLA. For example, the default route, which you create and then advertise on router 1 in lab 9228 would be a type 5. Type 6 is a multicast. Type 7, these are defined for what we call not so stubby areas. 8s are for BGP, which we won't deal with, 9, 11, 10. So you can kind of, every implementation supports these first 5 types. And the routers exchange them while they're talking to each other. So let's talk a little bit about those. So we've got our type 1 SLAs. Type 1 SLAs, routers use these to advertise their own directly connected links. These are router link entries. Type 1s stay on the area in which they originate. What the ABR will do when it receives a type 1 is turn it into a type 3. So a summary SLA. And then the link ID will be your router ID. Let's see, type 2. Let's talk about type 2. Type 2s are only used on NBMA, multi-access and non-multi-access broadcast. Multi-access and non-broadcast multi-access networks. In plainer English, that means Ethernet and frame relay. A DR, a designated router, will generate a type 2 SLA after it has established neighbor relationships on behalf of all of the DR and the DR other routers in its little circle. And these go to, these also stop at the area border router, in which case they will be turned into some sort of summary route. These are network link entries. We won't see these until we start working with DRs and BDRs in chapter 10. So a type 3, these are used to advertise networks from other areas. So a type 1 or a type 2 gets turned into a type 3. It goes and the ABRs exchange these with each other. They can move through other areas because they are representing the internal structure of other areas to ABRs. Your link state ID is going to be the network address instead of the router ID. So they can also be regenerated. So if a type 3 packet gets all the way across a backbone area to another ABR, it can be regenerated there. These routes are not summarized, but they do serve to advertise networks from other areas. So there's that difference between a type 3 and a type 4. Now, the type 4 will identify an ASBR specifically, and they will only be advertised by an ABR if it has noticed the ASBR. Say, for example, your ASBR advertises its gateway, and it tells the ABR about it. The information about that gateway goes from the ASBR to the ABR as a type 1. The ABR takes that type 1 LSA and turns it into a type 4. And it will go all the way to the other side of the network as a type 4. So they are this is more ABR to ABR traffic. Our type 5s, as I mentioned, is an ASBR advertising an external link, a non-OSPF network address. So if and the link state ID there will be the external network address that is being advertised. The routes are not summarized, usually because it's just an address. Like I said, with the address we saw in the route we saw in 9228 was a type 5 because it's an external route. You can more or less look at that E on the source code, the origin code, because source code kind of has a different meaning. The origin code, and there's a really good chance that that is going to be a type 5. And this is what these look like. Let's look at the routing table. So we've got our routing table entries. We saw a little of if you've watched the demo video, you've seen a little of this already. We've got an internal route. The green ones are intra area routes, that is within the local area. The orange ones, the IAs, the IA there actually stands for inter, not intra area. Inter from the Latin between, intra for the Latin within. And then of course we've got our E2 route here. This is an external type 1 or external type 2 route. Let's talk about route calculation now. Okay, one last thing to discuss before we move on to multi-area implementation. The order in which the routers are going to calculate their best paths. They're going to start with their type 1s and their type 2s, their intra-area. These will be step 1 here in green, and this one in green here. Those are intra-area. They'll do that first. The next thing they'll do is they'll do inter-area. That is routes learned from across the backbone, or learned from the backbone from across the backbone. Finally, they'll learn their type 4, their type 5 destinations, their E1 or E2 external routes. Say, for example, an OSPF external link to the cloud, which is like, say, RIP, EIGRP, BGP, static, whatnot. So they're going to learn the intra-area routes first. Then they're going to go find the best routes to networks in other areas. Then finally, the best path route to truly external networks, however they're shared. The next thing we're going to discuss is multi-area OSPF. So we'll be right back.